Hello and welcome to this video on electronic configuration. What we're going to be talking about in this video is we're going to be talking about how we draw the electrons around each atom. And it depends on how many electrons there are in that atom. So in the last video you might remember that I drew lithium, and lithium had two shells. Okay, but how did I know that it was going to have two shells, and how do I know where to draw those electrons? So first off, what do you actually need to be able to know how to draw? You need to know how to draw the first 20 elements. Okay, so the only elements that you are interested in how to draw are these ones here. Okay, that's all you need to know, and there's a pattern to how you learn them. So it's not like you've got to learn 20 different elements. All you need to know is how many electrons there are and how to draw them. So let's start doing that. Okay, so I've left the periodic table at the top so you can follow along as we go. Now what I'm going to be doing is I'm going to be using a dot and cross diagram. Now there aren't actually going to be any dots in these diagrams for the moment. That comes later when we start using them to illustrate bonding types. For the moment we're just interested in drawing our atoms and how the electrons are arranged around it. So I'm going to be using crosses. Now these crosses are going to represent the electrons. Okay. You're also going to see shells, as I've drawn in my previous diagrams. Now if I was to draw the dot and cross diagram for hydrogen, okay, what you also do is you also put the chemical symbol for the element in the centre. Now hydrogen has an atomic number of 1, so therefore it has 1 proton. Because all atoms are neutral, it has 1 electron. So hydrogen has just 1 electron in its outer shell. Okay, and we call this the outer shell because it's the shell on the outside. Okay, so what about helium? Okay, helium has an atomic number of 2. It has 2 electrons. Okay, so therefore we have 1 here, and the second one I draw at the bottom. Now there's a reason that I draw it like that, it's just because it makes me feel happy with the pattern that I end up drawing, and there is a reason behind the way in which I do it, because when you learn about electrons further along the line it makes more sense. Okay, so what about lithium? Lithium's the one that I drew in the last video, and I drew it with 2 shells. So what this tells us is this inner shell can only have a maximum of 2 electrons. After that, it then has to go in another shell around the outside. Okay, so this inner shell can have 2 electrons. So the first shell has 2 electrons in it. Now I'm going to write electrons as E-, okay, just because it's a nice little shorthand. Okay, now there's another way that we can illustrate this electronic configuration. That's using numbers. So the electronic configuration of hydrogen is just 1. Because it has 1 electron in its first shell. Helium has an electronic configuration of 2. Lithium, however, has an electronic configuration of 2.1. Now this could also be written as 2/1, whichever slash that is. Okay. Now we've drawn this in sort of a number of different ways here. So we've got a dot and cross diagram, which is how we can illustrate our electronic configuration, and then we've got the written version of the electronic configuration, shorthand. Okay, so how does it progress further down the line? So what I'm going to do, I'm just going to get rid of these examples here, and we're just going to look at each one as we go up to the 20th element. Okay, so let's stick with our lithium. Okay, now what I'm going to do is I'm just going to omit the middle part here just for the moment, just so that I can continue drawing with just one drawing. Okay, but what we've got, okay, is we've got lithium here. So this is lithium. Lithium has an atomic number of 3, so therefore it has 3 electrons. Now our next element, beryllium, has an atomic number of 4, so it has 4 electrons. Now I add the next electron in a sort of clockwise motion at the points of a compass. Now this is what makes sense to you if you keep doing chemistry beyond GCSE. So boron has an atomic number of 5, so therefore 5 electrons. Carbon, 6, so 6 electrons. Nitrogen, 7, so 7 electrons. Oxygen, fluorine, neon. Okay. Now, when I was drawing each of those, what you would have noticed is that on the side there is that their chemical symbol and their shorthand of electronic configuration was coming up. So now we've got our neon. Now what about sodium? Okay, now I could start drawing in bits on here, but I actually can't because this shell is now full. The second shell can only have 8 electrons in it. Okay. So what we've now got to do is for our sodium, which has an atomic number of 11, is draw another shell. All the way around the outside. Great circle drawing here. So here is my sodium. So it now has 11 electrons, so I'm just going to turn this into sodium. So it has 11 electrons around the outside, and it has an electronic configuration of 2, 8, 1. Okay, and that's sodium drawn, okay, using a dot and cross diagram and the shorthand for electronic configuration. So let's keep going. Okay, here we are at Argon. So Argon has got an electronic configuration of 2, 8, 8. But now we've got to add another electron. And you bet it, this third shell, it can only have 8 electrons in it. So where's our next electron going to go if we want to turn it into potassium? Well, we're going to have to draw another circle all the way around the outside. Here is our potassium. And calcium is just 1 extra electron just on the side here. Okay, so now we've got to the 20th element, which is as far as we need to know. 2, 8, 8, 2. Okay, and that's the pattern. Okay, this fourth shell for the moment, okay, as far as you need to know, it just houses 2 electrons. Okay, it does actually have the capability to have a lot more electrons than that, but just for the pattern that you need to know, that's it. 2, 8, 8, 2. So this is all well and good, but how is this actually useful for us? Well, the electronic configuration actually tells us something about where the atom is in the periodic table. Conversely, where an atom is in the periodic table tells us a little bit about its electronic configuration. So let's have a look at the calcium here. Okay, so the periodic table is split into periods and groups. Groups go down, periods go across. So if I was to write down the period numbers, we've got 1, 2, 3, and 4. If I was to write down the group numbers, this one up here, I haven't quite left enough room, is group 1. Then we've got group 2, this is group 3, 4, 5, 6, 7, and group 0. Okay, so what I want you to do is have a look at our calcium here and try and see if there's any pattern between the electronic configuration and the group and period numbers. See if you can spot it, pause the video, and then see if you're right. Okay, so let's see if you're right. Let's have a look at our electronic configuration. 2, 8, 8, 2. It ends in the number 2. Calcium, over here, okay, here's our calcium, is in group number 2. Okay. The group number tells us how many electrons are in the outermost shell. If I was to draw out something in group 1, it would have 1 electron on its outermost shell. Okay, what about the other number? What about our other number? So if we look at how many shells our how many shells our calcium has, we've got 1, 2, 3, 4. Lo and behold, our number 4, our period number. So the period number equals the number of shells. Okay, so the group number equals the number of electrons in the outer shell, and the period number equals the number of shells. 2 very useful bits of information. Okay, so what kind of questions could you be asked? Well, the obvious one that you could be asked is you're given an element and you're asked to draw its electronic configuration. The other thing that you might be asked is you might be given the electronic configuration, you might be asked to identify what group and period that element is in. Okay, those are the kind of things that you could be asked. Okay, so hopefully this video has shown you how to draw the electronic configuration of an atom given its position in the periodic table. From that, you should be able to draw a nice dot and cross diagram and also state, okay, what the electronic configuration is of that element. So, for instance, in our calcium, we're able to draw out this nice diagram, but also to quote the shorthand of the electronic configuration. To do that, just remember this pattern. First shell, 2 electrons. Second shell, 8 electrons. Third shell, 8 electrons. Fourth shell, 2 electrons. So if an element had 12 electrons, just as an example, just to finish, if we have 12 electrons in our element, okay, we know that it's going to have 2 in that first shell. That leaves me with 10 electrons. It's then going to have 8. Leaves me with 2 electrons. It's then going to have 2. Okay, and then by using this, I can actually look at this and go, well, it's in period 3 because it's got 3 shells, and it's in group 2 because it's got 2 electrons. So therefore, I've just written out the electronic configuration for our magnesium here. Okay, thank you very much for watching. Next time round, what we're going to do is we're going to start talking a little bit about what isotopes are, and we're going to be talking about relative atomic mass, and why, when we look at some of these numbers in our periodic table, those mass numbers that I've already talked about, they're not whole numbers, so we'll talk about that. So, thank you very much for watching, and I'll catch you next time.